Today I'm going to be showing you how to calculate the total resistance in series and parallel circuits. Now for circuits, for series circuits, it's pretty simple. I just got to add all the resistances since they are in a line. And then parallel circuits is a little bit more complicated since you can see the wire splits up and then they join again. So these are parallel circuits. So for series circuits, you just add the total resistances. So it'd just be 3 plus 3 plus 3. And the total resistance would be 9. And going with the Ohm's law, which is the total voltage equals the total resistance times current. And since the total resistance equals 9 ohms and the total voltage is 18, then the total current equals to 2 amps. And that's all throughout the little loop right here. Now for parallel circuits, it's a little bit different. The way you calculate this one is you do 1 over 3 plus 1 over 3 plus 1 over 3 and plus. However, if there's like more resistances, then you just add them over here. Plus basically 1 over all of the resistances is equal to the total resistance. 1 over total resistance, and that should give you the total resistance, RT. Alright, so let's go calculate that real quick. Alright, 1 second. Oh, okay, so that's 1 over 1, that's the total resistance equals 1. Because 1 over 3 times 3 is just 1. So 1 over 1 is 1. So RT equals 1. And that's 1 amp. So there's 18 volts and 1 amp, then there's going to be 18. Oops. This is ohms. Whoops. 18 volts and 1 ohm. It's going to be 18 amps. So I equals 18 amps. Now it's a little bit higher than this one. Be careful. It's a lot of power. Alright. Now we're going on to a little bit more complicated, but in the end it's all simple. So we're going to be solving this. We're going to be solving for all the currents and voltages on this little seemingly complicated loop here. But at the end we can just simplify and it should be easy. Alright, so we know that there's 18 volts going this way, conventional current. Oh, I forgot to mention. For parallel circuits, the total voltage is the same. And also for series circuits, the current is the same. Yeah, that's gonna help us solve this problem right here. Alright. So we know it's gonna 18 volts coming here and it's splitting up. But since it's splitting up into a parallel, this whole thing right here is parallel. And for parallel circuits, we know that the voltage is the same, since I just said it. So we know that the total voltage in here has to equal 18. Like this plus this equals 18, since this is in series, but these are in parallel. So all these in series has to equal 18. Alright, so starting off, we're gonna be oops, that was my phone. We're gonna be calculating the total resistance in this circuit since it looks the most easiest to solve. So it's R7, R8, and R9. If you go to the little chart here, R7, 8, and 9 is 5, 5, 10. We'll just go ahead and label these 5, 5, and 10. Alright, now we're gonna be using our little equation that we got from the last part. So for this part, we're going to be using 1 over 5 plus 1 over 5 plus 1 over 10. And that's 4.5, 1 over 0.5, and that's 2 ohms. So we're just going to imagine this whole thing is a big 2 ohm resistor. Alright? And then our 10 is 7 ohms right here. we're gonna imagine this is a 7 ohm resistor. Right, so 2 plus 7 is 9. So total resistance in here is 9 ohms, and the total voltage is 18 volts. So we're just gonna do our total equation, V equals IR. Alright, so we know that it's got 18 volts, and we're looking for I, and R is 9 ohms. Alright, just divide 9, and now we know that I equals 2 amps. Alright, so the current for all of these is 2 amps. Or for this one right here, 2 amps. Right here, 2 amps. Just for this one, because these are in parallel. And we know the current's different here than here. Alright, so 7 times 2, using our little equation, V equals IR. I times R, so we're just multiplying I times R. And that gives us 14 volts. Alright, so we know that this area is using up 14 volts. So what's 18 minus 14? That's 4. So we know that these 3 here take up 4. It has to be because it has to equal 18, like I said earlier. So we're just going to put 4 for all of these. Alright, look at that, 4. So 5 times what equals 4? Well, 5 times 0.8. Alright, just doing a little math here. 10 times what? It's 10 times what? 4, so it's 0.4. 4 amps. Alright, we pretty much got this whole area figured out. Now for this part, we're going to start with the smallest one first. R4 and R5. Go right here. 4 and 5. 2 and 4. It's 2 ohms and 4 ohms. Alright, let's go over here. 1 over 2 plus 1 over 4. That's 1 over 0.75 is 1.333 repeat. Alright. That's the whole resistance right here. And then these are in parallel. So R2 and R3, if we go to the chart, 3 and 5, 3 ohms and 5 ohms. And then these two are in series, so they're gonna be, you're gonna add them up. So this whole thing is like an 8 ohm resistor. Alright. And then this 8 ohm resistor is in parallel with this 1.33 ohm resistor. So to figure out the total resistance in this area, we just do 1 over 1.3333, repeat, plus 1 over 8. Yeah, and that should give us 1 over our total resistance, which is, if I get my phone over here, the total resistance is, so I'm not that good at math, 1.33 plus 1 over 8, that's like 0.0 or 0.875, and if we do the inverse of that, since it's 1 over 0.875, that is 1.143. 1.14285 7 to be very, very, very precise. Alright, we're just gonna imagine this whole thing right here is a 1 point whatever resistor. Alright, and then R1 is 1 ohm, and R6 is 3 ohms. Okay, so we're trying to figure out the total resistance, by the way. So 1 plus 3 is 4, plus that is 5.14. Alright, so this whole thing right here, just imagine it's a big 5.14 resistor. Whoops. 5.14 ohm resistor. And there's 18 volts going in here because when you split these up, it's still the same voltage because it's a parallel circuit. And parallel voltage is the same. Alright, so 5.14 times I equals 18. We just do the math here real quick. So 18 divided by 5.14. That's around 3.5. So the total current is 3.5. Yes, and that's for R6 and R1 because these are in series, and the current is the same in series. So R1 and 6. So R1 is 3.5, and 6 is also 3.5. Right. So 1 times 3.5 is 3.5 volts amps. 3 times 3.5 is 10.5 volts. Alright, so we know that this is using 3.5 volts, and then this part right here is using 10.5 volts. If you just add these up, it's 14. These two are using a total of 14, and 14, or yeah, 18 minus 14 is 4. So we know that the total voltage in this area is 4. Yeah, 4 volts. This must be using 4 because it has to add up to 18, because they're in series right there, in this part right here, in parallel. Yeah, whatever. Right. So 4. So then we know that 4 goes in here. We know that for resistance 4 and 5, it's 4. So we go to here, 4, 5. We know it's 4 volts. So now we know that this is 1 amp and this is 2 amps. Alrighty, and we're almost done. We just need 2 and 3. So for 2 and 3, we know that the total voltage has to equal to 4. So yeah, the total has to equal to 4. So I know that 5 plus 3 is 8, just off the bat, and 4 divided by 8 is 0.5. So we know, yeah, the current is going to be 0.5 and a half. So 3 times 0.5, that's 1.5. And this has to add up to 4. 5 times 0.5 is 2.5 amps. So 1.5 plus 2.5 is 4. So that adds up. That's perfect. Yeah. Alrighty, we got it. We got the whole thing right here. Yeah. Oh, yeah, I forgot to calculate the total resistance. So for the total resistance, we just do 5.14 right here. That's for all this right here. 5.14. 1 over 5.14. Total resistance in here was, if I remember correctly, was 9 ohms. Yeah. Plus 1 over 9. Just do that real quick. 1 over 5.14 plus 1 over 9. 0.30566. So 1 over 0.30566. Whoops. 1 over 30566. That's about 3.27 for the R total. Alright. And that's ohms. Now we just divide 18 by that. So 18 divided by 3.27. That's 5.5 aroundish. So that's 5.5 amps, and that's a total current and total resistance. Alright, hope you enjoyed. Goodbye.